Good afternoon. Myself, Arup Patani, Faculty of Physics, ICB College. I'm doing my PPHD research work in Arts Environment and Solar Terrestrial Physics Laboratory, Department of Physics, Tripura University. Topic of my presentation for PANI Conference 2021 is influence of the remote celestial event like gamma ray bursts GRB 1901-14C and GRB 1109-18A on the total electron content of the Earth's ionosphere, a case study. This is the outline of my presentation. Ionosphere. We all know about the ionosphere. This is an important field of study for physics research. Ionosphere is the layer of plasma of the Earth's atmosphere having electrons, electrically charged atoms, and molecules. It extends from height uh, of 50 km to more than 1000 km from the surface of the Earth. It has different layers: D layer, E layer, F1, F2 layer during daytime. In night time, F1 and F2 layer combines to form a single layer. The different layers have different temperatures and of course different electron densities. Gamma ray bursts, shortly GRB. Gamma ray bursts or GRB are the most energetic phenomena in the universe due to explosion in far away galaxies, that is explosion of stars. Vast amounts of energy is released as gamma rays and it races through our solar system. During a supernova explosion, when a high mass star implodes to form a neutron star or black hole, an intense radiation is released in the form of gamma ray. This is termed as GRB or gamma ray burst. It is two-step radiation process, namely prompt emission, which lasts for few minutes or few seconds, and afterglow emission, which lasts for few to several days. This is the region of our study. The red encircled dots show the different stations in the Asian Australian region in low, middle, and high latitudes in the longitudinal span of 50 to 110 degree. These are the IGS station, that is International GPS Service Network Service stations. Objectives of our study. First one, to investigate the ionospheric response of two gamma ray burst or GRB occurred in the remote outer space. Number two, to explain the possible mechanisms which causes the observed response of the ionosphere. Data sources and methodologies. Data sources. Here we have used the total electron content data or TEC data. We have used solar interplanetary and geomagnetic index data. We have used international coordinates data. All these data are obtained from website. Tag data are collected from IGS station, that is International GPS Service Network stations, in high, middle, and low latitudes in both uh, southern and northern hemisphere in the Asian Australian region. Methodologies. Here we are interested about the parameter, ionospheric parameter, TEC, that is total electron content. This parameter TEC or total electron content is connected to GPS signal. We know about GPS satellites, and if we consider a cylinder along the path of the GPS signal, that is along the line from GPS receiver to the GPS satellite, and we consider a cylinders, cylindrical volume whose cross-sectional area is 1 meter square and length is equal to the distance from lower boundary of the ionosphere to the satellite, then total number of electrons contained in this cylindrical volume is known as total electron content of the ionosphere, or TEC shortly. This is expressed in TECU and it corresponds to 10 to the power 16 electron per meter square. The tech data obtained from different IG stations are in Rhinix format. These are processed using the software developed by Gopi Krishna Simala. Here we need background tech values, that is monthly mean. These are calculated by taking the average tech values of 10 international quantities. Results. As we have mentioned, uh, we considered here two gamma ray burst events. First one, GRB 1901 14C, and the second one, GRB 1109 18A. These two graphs show the variation of different geomagnetic parameters and solar wind or solar parameters, namely average magnetic field, jet component magnetic field, solar wind speed, solar wind pressure, electric field, etc. In both the graphs, we find red dotted vertical lines. These lines indicate the time of detection of these two GRV events from our Earth. Now, from these two graphs corresponding to different two events, we find that the variations of different geomagnetic and solar parameters are steady during the GRV events, that is in the prompt emission period and in the afterglow emission period. That is, the days during the GRV events are magnetically white. This is the experimental results of the first event, GRB 1901 14C, which occurred in the year of 2019 on 14 January at the time of 20.57 UT hours. And the left panel corresponds to the variation of the total electron content values at the stations in northern hemisphere, and right panel corresponds to the tech variation at the stations in the southern hemisphere. Here we have colored graphs and black dotted graphs. Colored graph corresponds to the disturbed tech variation, and the black dotted lines corresponds to the background variation or monthly mean tech variation. Here also we find two vertical red dotted vertical lines, which corresponds to the detection time, spectroscopical detection time. Near these two vertical lines, which corresponds to the prompt emission period, in the low and middle latitude station, we find no remarkable variation in tech values, but in higher latitude stations, we find an abnormal variation in tech values in the prompt emission period. In the following day, that is, in the afterglow emission period, we find the variation from the monthly mean in almost all the stations in high latitude, low latitude, and middle latitude. That is, the variation is isotropic, and the maximum tech values vary from 1 to 3 tech units in different stations. This graph shows the variation of tech values during the second selected event, GRB 110918A, which occurred in the year of 2011, September 18, at the time 21.26 UT hours. Here also two vertical lines corresponding to the detection time, and during the prompt emission period near these two vertical lines, we find no remarkable variation in tech values. But in the following day, that is in the afterglow emission period, we find remarkable variation in almost all the stations. That is, here also isotopic variations are observed in the tag values. And the maximum tech values vary from 5 to 8 tech units. Our results are summarized here. Discussion. Here, the uh, days of detection of event are important to us. Why? Because our first event occurred in 2019, January 14, which is winter season. Our second event occurred in the year 2011, September 18, which is autumn equinox. During these two events, that is during uh, time of these two events, as we know, cloud activities are less. That is lightning, cyclones, etc. So the possibility of disturbance due to cloud activities are less on the total electron content of the ionosphere. Secondly, as it is obvious from the graphs and list of international coordinates, the days of the event, prompt emission period and afterglow period were magnetically quiet, as obvious from the graphs of geomagnetic parameter and solar wind parameter, solar parameters. So here we can say that the tag variation, remarkable tag variation, mainly in the afterglow period, may be due to these two celestial events, the gamma ray burst events, which occurred in the outer space. Our our conclusion can be drawn in this way. Number one, from the literature survey, it is found that there are very few studies on JRB, and there is no study on the afterglow influence on the tech, and the influence of such a long duration JRBs is reported for the first time. Secondly, this study answers an important question for scientists regarding the possible potentially harmful influence of the remote celestial event on our celestial space. Lastly, the authors expect this study to be useful in understanding the ionospheric response to gamma ray burst and also in validating the theories and physical mechanism established till to date. Uh, these are the references. Acknowledgement. I am grateful to Dr. Anirban Guha, Associate Professor, Department of Physics, Sipur University, and other faculty members. Dr. Anirban Guha guided this research work. I am thankful to the organizing committee of Physics Academy of Northeast Pune for providing me the opportunity of to present this research work. Thank you all.